Hello everyone. In the previous part, I have discussed how you can use Pandas Data Frame, what is data frame, and some basic functions of data frame. So in this part, I will explore some more functions of data frame, and we will analyze the dataset. The dataset which I am gonna use is available here. As you can see the dataset, and we will analyze this dataset with the help of pandas data frame in this part. For that you must import pandas as pd, and then I will use pd.read.csv to read the data from this link. So just copy this link and then paste it here, and then when I click on df it will print all the data. So as you can see, there are these number of rows and 21 columns in my data set. You can see all the columns here. So you can see all the columns here. When I print df it will print a whole data set, as you can see. Next is df.columns. When I use data frame dot columns, then what is the output? I get all the columns. For example, you can see the columns age, job, marital, education, default, housing, loan, contact, and all the columns you can see in your data set, as you can see. So when I click on df.size, it will print me the number of values in my data set. So number of values in my data set are, you can see, these number of values are in my data set. And df.shape I have also explained in my previous part. df.shape will print the number of rows and number of columns in my data set. Very simple. And df.describe, it actually provides the summary of the statistics. So when I use df.describe, it provide me these values for each of the column. It provides me count, mean, standard deviation, minimum, 25% variance, 50%, 75%, and maximum value. As you can see that if I see the age column, there are 41188 values in count column. Similarly, all the columns has these number of values. And minimum age is 17, maximum age is 98. Similarly, you can find the minimum duration, you can find the maximum duration, you can find the statistics of each of the column, as you can see. And similarly, you can find the mean of all the age value, you can find the standard deviation of all the age value, minimum of maximum value. Next is df.dtypes. df.datatypes will provide me the data type of each of the column. As you can see, age is integer value, job is object value, duration is integer value. So there are some float values in my data set. So you can find the data types of each of the column. Next, when I click on df dot, when I type df dot data type dot value underscore count, it will provide me the number of integer columns in my data set, the number of float columns in my data set, and the number of object type columns in my data set. df.head, I have also explained this in my previous video. It provides me the first 5 rows of my dataset. As you can see, the first 5 rows of my dataset you can see on the screen. Very simple. And df.tail provides me the last 5 rows of my dataset. So df.head provides me the first 5 rows, and df.tail provides me the last 5 rows of my dataset. And if you want to print only the age column, you can simply pass df square bracket and then age column, and it will give me the output of the, it will provide me the data of only age column. As you can see, name is age and length is this one. These, it means there are so many values, and data type is integer 64. And similarly you can print the df job, so it will provide you the job of the each of the row. You can see 0 is housemaid, 1 is services, and so on you can find. And if you see you, if I click on df job, it provide me all the values. For example, this value and this value has services job, you can see. And if I write df job dot value underscore count, it will provide me the data category wise, job category wise. For example, the number of admin, the number of job where the job is admin is 10422, blue collar is 9254. So this way you can print the value count of any of the column. Simply provide df square bracket name of the column dot value underscore counts. It's very easy. And if I type df job dot value underscore count normalize equals to true, it will provide me the percentage of that. For example, the number of admin jobs are 0.25%. It means 25% of all the values which are in the data set. There are total values, if of the data set, there are 25% values of the admin, 22% values of the blue collar, 16% values are of technician. So if I provide normalize equals to true, it will provide me the data like this. And if I so see, now this value has 0.253035. I can round off this value to two decimal places. So simply just provide the function name round and pass this value comma 2. So it means it will round off the value by two decimal places. As you can see, compare these results. Here I have provided normalize equals to true, and here I am rounding off the value to two decimal places. Similarly you can filter the data. So if I provide df dot location colon 6 comma this, it means it will provide me the first 7 data points. It will provide me the first 7 data points using the location method, but for the variables job and marital. So it will provide me the first 7 values of the job column and marital column. It's very simple to use this. And similarly we can achieve the same result by using iLocation. If I use location method, if I use location, then I have to provide the column name. And if I provide the iLocation, then here I have to provide the column name as the integer value. So 1 comma 3 integer value means, see my complete data set. So see, this is the 0 index, this is the 1, this is the 2, this is 3. So I will provide 1 comma 2 or 1 comma 3. You can type here. So okay, so I location 1 comma 3, it means job and education. So let me show you the data. 1 0 index is age, 1 index is job, 2 index and 3 index. So job and education column means I am getting the data of only these two columns. So with the help of iLocation, I will provide the column as integer, and with the help of location, I will provide the column name. So this here I am printing the whole my data set. Okay, so conditional selection. For example, if I want to select only data where the age of the person is greater than 50, then what I will do, I will use df age greater than 50 and then I pass it in the data frame. So very simple, it is a conditional selection. So here you can see I am getting only 7180 rows because only these number of rows has age greater than 50. And similarly, see, if I write like this, I am getting all the columns. But if I am not interested in getting all the columns, if I am interested in only particular columns, then what I will do, I will use df dot location and then see the difference. Here I am getting all the values which where age is greater than 50, and here I am getting only these two columns. So very simple, df dot location. Here I will pass the condition, and here I will pass the column name which I want to print. So I am getting only the age and job values of all the columns, all the rows where age is greater than 50. It's very simple. Similarly, you can drop the columns in the result. For example, if I want to, if I am not interested in these two columns, job and education, I can drop in my result. So df dot drop, and in the scale, in the bracket I will pass columns. In the bracket I will pass columns name. So job and education I don't want in my result, I want to drop these two columns, I will pass in the. So you can see now I am getting only 19 column, and in my original data set there are 21 columns, and I have dropped two columns, job and education. It's very simple. So this way you can drop the as many number of columns as you want. Just pass the column name here. And if you want to add a new column, so simply, for example, I want to add a new column. See, in my original data set I have 21 columns, and now I want to add new column. So df, in the square bracket I will pass the name of the new column equals to the value. So it will has English value for each of the row. So you can see, if I print df, you can see there are 22 columns. In my original data set there were 21 columns. Now I have added one new column, English language, and now I have 22 columns. And let me show you the values. So you can see the last column is language English. So I have added this column to my data set. Very simple. And you can see the name of the index of index is starting from 0 1 2 3. And if I want to rename the indexes, I can rename. So df dot rename, in the bracket I will pass the index. For example, 0 index is Rahul, 1 index is Ram, 2 index is Rajan. And when I print the data, you can see 0 index, 1 index and 2 index are renamed to Rahul, Ram and Rajan, and I have not renamed the remaining indexes. So I am getting 3 4 and these values, but I have renamed the 0 index, 1 index and 2 index. So I am getting in the result the name of the index, the new name of the index which I have just renamed. So 0 is Rahul, 1 is Ram and 2 is Rajan. Very simple. And similarly, you can also rename the name of the columns. For example, if I want to rename my column education to edu and day of week to day, education to edu and day of the, so you can write like this, df dot rename columns. See, previously I have renamed the index. So index is row wise, but now I want to rename the columns. So df dot rename, and in the columns I want to rename education to edu and day of week to day. So just type this, and you can see in the result of, in the previous result, see the name of column was education, and now it is edu. And similarly, day of week, see the day of week, and now I have renamed to day. And you can see I have renamed the column to day. Previously it was day of week, now it is day. Very simple. So this way you can use the all the functions of the data frame for better analyzing the data. That's all for this lecture. Thank you for watching.